Assalamualaikum warahmatullahi wabarakatuh. My name is Zaim Amin and I would like to present about my project, which is Face Mask Recognition System. The project is supervised by Dr. Arifuddin Bejoret, and the panel that judged me are Professor Madya Dr. Maisara binti Osman and Dr. Shikun Anwar bin Hamzah. For the first slide, I would like to talk about the project background. The usage of face masks has become habit to minimize the spread of virus among the people. As example, since the COVID-19 disease has appeared around 2019, face mask has always been used by people to stop the virus to spread. And then, the use of face mask also to protect the user from something that could harm the body by inhaled process. As example, many of harmful substances can absorb easily by our nose that can damage our body system. To prevent the problem, face mask recognition system will be developed to encounter this problem, and the project will detect the condition of user by the camera view whether the person is using mask or not. Okay, for the problem statement, first of all, bad environment of workplace that can affect the worker health. It is because for who work in the factory and interact with chemical substance that can be harmful to our body. And for the second point, the irresponsible worker that take easy about face mask usage is because sometimes the worker just feel that it is okay, but it may harm their health by the long-term disease. For the objective part, first of all, to develop the face mask recognition system for workers to access the building, and then to develop an algorithm using deep learning model to solve the face mask usage problem by face mask recognition system, and then lastly, to verify the ability of the system based on the variety types of user and situation. For the scope of study, a computer with i3-10100 processor, 8GB RAM with GTX 1050 Ti graphic card, and a HD webcam has been used to run the system. And the software that used to run the system is Python. Then a data set has been created and divided to two groups, which are mask and non-mask. Each of dataset consists of around 500 images that will be fed into the model, and image that used must have a transparent background. The camera will be used with the program on the computer to run the visual recognition in detecting the face mask usage based on user. There are two types of data that have been taken, which are outdoor testing and indoor testing data. The ability of the system to capture the image to be processed has been taken based on many users that has been captured on the camera view. And then for the methodology part, first of all, we go through the creating dataset, which consists of two folders, which are mask and non-mask. And then we go to the image setup. The image has been set up to have a transparent background with the required pixel. And then we go into the data feeding process. Data feeding process is the process where we fed the data set that we have gathered into the deep learning model and make a training. And lastly, the image capturing process is the way to recognize the user whether using mask or not. And as we can see at the flowchart, the camera will detect the visual, and then the visual will be processed based on the dataset. If the mask have been detected, the green frame will appear, but if not, the red frame will appear. And as we can see here, here are some of the sample images for each part of method. First of all, creating dataset, which contain two folder, and then image setup with the image with transparent background and required pixel. And then data feeding process is the part that we train the data set, and then the image capture process is the last part for this system. We're moving to the next part, which is result. This is the graph for the training loss and accuracy in face mask recognition system. Those value has been taken based on the epoch of the system. The system required 20 epoch to finish the training process. At the end of the process, if the validation accuracy is higher than training accuracy and the training loss is higher than validation loss, so the training has been well. So to test the accuracy of the program, a simple test has been done to observe the change in the output from the frame that have been developed. At the left image, we can see if there is no mask on the user, the red frame will appear and show no mask. And at the right image show that the user used the face mask, and the green frame appear and told they are using the mask. In this part, I would like to tell to you about the result from the simulation that I have recorded a video for the simulation. Okay, here we can see that when there are masks, the green frame will show that we are using mask, and when we are not using mask, the red frame show that we are not using mask. Okay, okay, if we moving to the result, this is the result that have been taken from the outdoor testing. The outdoor testing that has been done at SK Gading, which consists of the student from year 3, year 2 and year 1, which the teacher. First of all, we moving to the percentage of the detection. At 8:30 a.m. until 10:30 a.m., the detection show 100% detection, but when it is different at 8 a.m. and 11 a.m. because of the ability for the camera to detect the person or the user that standing in front of the camera view, but the user has not been detected from the camera. That is why the percentage is low for both at 8 a.m. and 11 a.m. And then we moving to the data that have been collected from the indoor testing. Based on the data that collected based on 10 people shows that the percentage is above of 95% for all of the value that have been collected. From those data that have been collected, a comparison between two testing have been done. For the outdoor testing, there are lack of light, which many change in brightness. Too many change that make the image to become blur. Also can give result at the right time with a better brightness at the place. For the indoor testing, good lighting has been used in this testing. The characteristic of image can be recorded clearly, and then always give accurate result at all time. And for the discussion part, from the two results that have been compared, indoor testing gives the better result compared to the outdoor testing. Is because the light that provide from the room for indoor testing enable the camera to record the best image of user to process. Image taken indoor testing are clearer than the image taken in outdoor testing, while the video capture by the camera become blur for the outdoor testing because of the inconsistent light. So for the best use, face mask recognition system should be used in the indoor environment. And last but not least, for the conclusion, the best condition to use the program for the face mask discovered by applying the better lighting when using the camera, because by enough lighting applied, it will make the image to become clearer than usual. But lighting also must not have any of changes frequently that can make the capturing process to become obstacle during the image processing part. Moreover, the distance between the camera with the user must be not too far, around 15 to 30 centimeter, so the user detected can be more precise and the image processing can be done well. So it is the end of the slide. I would like to thank the viewer to spend time to watch and listen to my presentation about my final year project. Thank you.